Welcome back, guys and girls. So a lot's changed over the couple of years, since we last created a video in this series, minus the mini update. And I just want to go over quickly what needs to be done. So opening up the Unity Hub, we're going to navigate to our project that has the Roguelike tutorial, and we're just going to update the editor version to the latest LTS version for 2022, which is in my case 2022.3.20 before selecting current platform, which will obviously be Windows in this case. And we're just going to click open and change version. We'll come across this error. It's all right. We're just going to click continue. Alrighty, with that now done, we're going to navigate to our window, Package Manager, and making sure that in project is selected, we're going to navigate down to our Vscode Studio Code Editor and remove that package. Now the reason being for this is Microsoft actually updated the Visual Studio Editor package, which means now it will generate the solution for our VS Code editor, allowing us to use it. However, I find that I keep reaching issues using this package, so I'm going to go ahead and remove it. I'll leave the URL down below in the description so you don't have to type this out. We're putting in github.com/chizuru/com.tisk.ide.vscode.git #upm before clicking add. With that done, we're good to go. For anyone wondering what that was, basically it adds a whole range of new features that you can use with VS Code and also automates some simple things. Just quite frankly allowing you better control over your config files and how you want your project files to be contained. So instead of having a messy root directory full of sysprog files, now you have some lovely folders that contain them all. With our project now being supported by the latest LTS version and a better package to allow better integration with our VS Code editor, we're going to now get started on creating our first two new assets, which is a closed door and an open door. So exciting. So going into Window, 2D, and Tile Palette, we're going to navigate to our Resources folder, Images, opening up our sprite sheet. We're going to use the plus image as our closed door, making sure to save it into the palette, and renaming it closed door. Followed by the / for our open door. Closing the tile palette, and we're going to open up our MapManager. With our MapManager now open, we're going to go down to our tile bases and add in both a closed door and an open door tile base. Followed by a new interactable map in our tile maps. Heading over to the getters, we're going to make sure to add up both our closed door and open door tile base, followed by our tile map. Moving down to our generate dungeon method, which you can get to by using the outline. Since we now have an interactable map, we want to add that tile map to our dictionary. Also, you're going to find yourself running into some issues, both with saving and with our FOV. And just before we continue on, we're going to add a new public method below our setup fog map method, which is called public void update tile, with its parameters being entity. This public method is going to help control the closed and open state of our doors. So first, adding in a vector3 int of grid position. We're going to add an if statement for our entity size. for adding a for each to go through all the positions in the entity's occupied tiles. Setting our grid position to the floor map.world to cell. And then adding a new if statement, with our condition being tiles contain key of grid position. And now from here we can control our door state. So if tiles grid position name equals closed door name, you will say interactable map.set tile, passing out a grid position open door, followed by tiles grid position dot name equals open door dot name. Else, and we're just going to copy and paste what's within the for each, making sure to change the pos to entity transform position. Now moving down to our reset method, we're going to add interactable map.clear all tiles. And lastly, we don't want to forget about our load state, otherwise we're going to have some issues later on. Going down, we're going to add a couple of new if statements, which is just to set our closed door and open door tiles. Alrighty, with MapManager done, we're going to move over to the procgen script. Now, to add doors is relatively simple. We're going to be using our tunnel coordinates and the wall positions of our rectangular rooms. So, starting off, we're going to add a new private variable, which will be a hash set of vector3 int named tunnel chords. Making sure to initialize it before moving over to our generate dungeon method. Now here we're going to move down to just after our room and tunnel generations. I'll just comment it quickly. Add doors to the rooms. And it's going to be a for each of our rooms with a method called place doors. Passing in our room and rooms. Now let's just scroll below this method. We're going to add a new place door method. Private void place doors. Passing out a singular rectangular room and list of rectangular rooms. Now we're going to create a new, actually before we continue, we're going to go into our rectangular room script. Scrolling down below, just on the overlap, we're going to add a new method called getWallPositions, which is going to pass a list of vector2 ints. So we'll add a summary quickly. Return a list of positions along the walls of the room. Say public list vector2 int walls positions, and we're first going to initialize. That's crazy. And we're first going to initialize a vector2 int called WallPositions, followed by getting the top and bottom walls. So the first for loop is top and bottom, and then the left and right. And just before we continue, just got to correct this code here. So it's going to be int I equals, actually we'll just rename the I to j using F2. And we're going to say j equals y +1, and it will iterate for j less than y plus height -1. Alright, continuing. Let's go back to our procedural generation script, where we're going to get our wall positions, or I should say our potential wall positions, followed by adding a for each. That cycles through all the available wall positions. Wall positions. Setting a vec3 int of position with our position values. Now here's all the logic that we're going to do. So first, we need to check if the wall position is adjacent to a floor tile position. So if is adjacent to floor, passing a tile position, and it's not equal to is part of another room. This is important actually. Passing in our tile position, our room list, and our room that's currently iterating through. And because we don't want this to be weird, we want to say not adjacent. So this is the third method, not adjacent to another door. Otherwise it's going to be pretty strange. You may like the wild look, but I don't. And we'll just set these values first so you can stop hassling me. Going to remove any floor or wall tile, any wall tile, before setting our door. Alright, we have 3 methods to add, so let's get to it. Starting with our is adjacent to floor method. So private bool is adjacent to floor. Its parameter being position, of course, with int or vector3 int. We're going to be checking the 4 adjacent tiles up, down, left, and right of the tile position. Initializing it with an array, of course. And we're going to place into the array position. Class vector up, down, left, right. Scaling it off. Once we get all the adjacent tiles, we're going to check if it's a horizontal or vertical corridor. So creating a bool is horizontal corridor equals passing in our MapManager's get tile with the adding both the left and the right tile are the conditions, followed by a vertical corridor, adding in of course the top and bottom tile positions. Finally, we're going to say if is horizontal corridor or is vertical. We're going to check the orthogonal direction for walls now, just as a little confirmation, if you will. So orthogonal, orthogonal direction. That's not right. Left and vector3 int. Opposite direction, down, right. Yep. Alright, after with both orthogonal directions now set, so adding a new if statement, adding an exclamation point, MapManager, instance of floor tile, getting that tile, floor map, sorry, getting that tile, and getting the orthogonal direction tile that we set earlier, and get in the opposite direction. So if both of these are false, then we can return true, as it's a valid position. Otherwise, after both of these if statements, we return false. So this is why you don't trust Copilot sometimes. So it looked right in my head, but so it's not actually vector3 int.up. We have to use our JSON tile positions. So my apologies, because we have position plus vector3 int.up, unlike here where it's just vector3 int.up, which is incorrect. So changing this to adjacent tiles 0 and 2, so top and left, and bottom and right. Alright, moving on to our is part of another room method. These are quite simple. So we're creating a new private bool. Is part of another room. Passing in our parameters. Okay, this IntelliSense is actually correct. Passing in our parameters before creating a new for each, which will cycle through all available rooms, comparing our single room, our current room, to the room within all of the rooms. And if it's not equal and the getBounds int dot contains position, then it will return true, meaning it's part of another room. Otherwise, it returns false. Finally, let's go to our adjacent to door method, which once again, IntelliSense is incredible, which will be a private bool of is adjacent to door with parameters of vector3 int in our position before we create a new adjacent tiles array, followed by a for each that cycles through all the adjacent tiles, checking if there's already a door in that position. If there is, then it returns true, otherwise it returns false. Lastly, we do need to remember to fill our tunnel coordinates, otherwise this is all pointless code. So going to our tunnel between method, and just below set floor tile, we're going to say this dot tunnel coordinates dot add, passing a new vector3 int of our tunnel coordinates. Alright, and with that, our procgen should be complete. So moving on, we're going to go to AdamMilVisibility, as we need to make sure that our compute is being used properly in regards to our interactable map, which can be easily done by simply going to our blocksLight method. And here, we're going to cut this and create a new if statement of map instance. So we're checking our MapManager to see if the obstacle map has a tile in that position, which will return true. Else if MapManager instance interactable map has a tile, and we need to make sure that that tile, so if it has a tile, of course will be true, and we have to check that that tile is called closed door. Otherwise, if it gets any tile, then it's going to be some issues, as you'll find that your open doors now are blocking your view, or possibly if you add a new interactable tile or item, you might find that there's a little black tile, which is a bit of an issue. All right, and of course returning true, else we return false. Now moving to our entity script, we're going to make sure that our tile is always updating whenever the entity moves by saying MapManager instance dot update tile, passing in this, and that's our field of view done and sorted. But there's only one last crucial script that we need to change, and that's our AStar script. As now, because we have doors, the AI is not going to understand what's going on, and it can't process as there's going to be no node in that tile where the door is. So heading to our AStar script, we're going to remove getPath because I stopped using that and I forgot to remove it. Teehee. Going to go all the way to the top of the script, heading over to our find neighbors within this if statement here of neighborpos not equal to start and MapManager.instance. We're going to cut this out, just above it, we're going to add a new boolean called has floor or door. Pasting that back in, going to add our interactable map there as well. And of course, adding has floor or door to our if statements condition. All right, opening up our Unity editor, going to move over to our dungeon scene, opening the MapManager game object, and just duplicate the floor map before renaming it Interactable Map. Selecting our MapManager game object, we're going to set our new closed door and open door tiles, followed by adding in our interactable map to our tile map list. And with that, going back to main menu, we can play the game and press play. Now we should find a bunch of rooms, a bunch of doors, and they're all placed correctly. That is adding doors to our roguelike game. Not so simple and simple at the same time. It's just adding slight additions here and there, getting a formula that works for you. Anyway, I hope you enjoyed this part of the series. I tried something a bit different this time, where I talked more and typed along with you as I was saying it, as there have been several requests to do so. Anyway, there will be one more part after this, which would be our magic system, before I conclude the extra series, as it's been over a year and a half since I started this series. And while there's a lot I would like to optimize, there's a lot I would like to do, unfortunately I don't have that much time anymore. I started a new position which is pretty demanding, and with the licensing and .NET issues that Unity currently has, I'd like to move on to Stride, just to take advantage of all the new additions that we can use with .NET, for its nugget packages, and of course its syntax sugar, which is something that I really enjoy using. I may return to Unity in the future, but we'll see how that goes, assuming if they change to Net 8. Anyway, that's a topic for another time, I suppose. I will see you in the magic system. Take it easy.